Hi, I'm Bri Lawrence, and my study is modeling the vegetation effects after the Dixie Fire using change detection. All right, a little bit of history on just wildfires in general. They're unplanned. Usually they're naturally occurring events. They happen in forests, grasslands, prairies. Since 1983, reported wildfires have increased nationally, according to both the Fire Service and the National Integrity Fire Center. Here's a chart showing all of that data going back to 1983. In 2021, the fire season was over 7 million acres had burned, and fire suppression costs reached 4.3 billion. And that was the year of the fire that I did my study on, the Dixie Fire. Wildfires themselves, they change soil properties. They can damage watersheds by the flooding that is caused after the fires can travel down to the watersheds, which ends up polluting the water sources for a lot of people and plants and animals. They also can contribute to soil erosion and property damage. All right, so here's an overview of the Dixie Fire. The burn extent itself is shaded in the dark red, and it happened on July 13th, 2021 in Northern California. It affected 963,309 acres, and it has held the record for being the most expensive wildfire in terms of suppression efforts. Probably because it took like almost 3 months or a little over 3 months just to suppress it. And that total was 637 million to fight it. All right. My goals for this study are to acquire and compile pre and post imagery data, perform vegetation analysis, calculate the normalized burn ratio, or NBR, and the difference NBR. Also to calculate the normalized difference vegetation index, NDVI, and map all of my findings. And here's a little picture of just the smoke itself from the Dixie Fire. All right, so all my data was collected using USGS Earth Explorer. The paths for my data were path 44 and row 33. And again, I took pre-fire and post-fire images. And you can see I just did like a map extent of the area and kind of filtered through based on like cloud coverage. If the clouds were heavy, although my bands could penetrate the clouds, I just selected better images. All right, methodology. Using data management tools in ArcGIS Pro, the bands will be compiled together. I use band combinations of 4, 5, and 7 for vegetation analysis. For NBR, I use 5 and 7. And for the differenced NBR, the pre-image was subtracted from the post image, or you could also use a raster calculator to do that. And then for NDVI, I use bands 5 and 4. So I'm going to show you all my results, but I'm just going to give you a little synopsis real quick. My vegetation analysis shows how dense the vegetation was prior to fire. You'll see that in a second. The NBR in the pre-fire image, there was a lot of highs. Post show a lot of low values, and I'll get into that. The differenced NBR, majority of the fire boundary has low to high severity burn scars, and on the image right here kind of can show you like low, moderate, and high, like how bad it was for these examples of fires. And the NDVI, the post-fire, has clear indications of bare soil compared to the pre-fire. Okay, all right, so this is my vegetation analysis. So the left is the pre and the right is the post. And then you can see the bands that I used, and the bands 4, 5, and 7, those are picked just because they show the vegetation and the moisture content. So pre-fire, you can see that there's more moisture in the vegetation because it's healthy, it's growing. And then post-fire, you can definitely see there's a change because it's been burnt. Next, the NBR. Again, you can see my low and my high values for this. For the pre-fire, there's high values or indication of healthier vegetation. And then the post-fire, there's a lot more low values, and that's because of the fire itself, you know, killed all the vegetation. All right, the differenced NBR. Showing here, I did like percentages of each category, and I did like the color amp to match those categories, and you can see the chart here. And again, about 1.5% is enhanced regrowth, like high regrowth, and 8.5 is the low enhanced regrowth. And a good majority were low severity and moderate low severity, and only 9% was high severity. And my last image is the NDVI of pre and post fire. And you can see that the sand is more prevalent on the post fire as it's depicted. I just did brown to kind of like represent that compared to more of the dense vegetation, the green, if you will, like on the pre-fire images. That's the symbology I picked, and you can see in the legend. And then I have a classifications in the little chart. So get back to my conclusions. There were some data challenges. I didn't originally start with this fire, and I ended up changing it to this one due to some data was missing in the images that I downloaded. But overall, I think by doing this, I think it would be helpful for local and federal agencies, and they can determine like where bare ground exposure or scarring has happened. It could help determine where erosion is, which can lead to flooding and hurting those watersheds in the area. And it could also help determine where vegetation regeneration either has occurred or where they need to restore that. And here are my references. Questions?